thank you to our amazing annual sponsors, especially the business school, who's been great at a lot of supporting us in a lot of ways. They have a lot of masterclass series if you want to go and look at their website, and also Stratus, who has been a continuous partner in a lot of different ways as well. Again, coming on board, and supporters who has been helping us in different forms as well. Site host, Rediclus Digital, Integration Works, Crescent Consulting. Yes, everyone is welcome. And can you make sure everyone is muted, please? Hacker.
And I know that
I'm going to mute you, maybe. Hacker, do you want to mute yourself for me? Thank you, Hacker. Fantastic. So thank you for, again, annual sponsors and supporters. We couldn't do it without you, so thank you again. And we are going to the next slide. We're going to make it quick because Adrian apparently has a lot to talk, and we know we have a lot of things to hear from him and also talk to him. So the first thing is 2024 committee. So we are hiring new people, new energetic people who wants to contribute to the Canterbury and New Zealand ecosystem. So yeah, Andy, looks like you've applied. So if you feel like really passionate about this, like really homegrown voluntary board, please, non-for-profit board, please feel free to reach out here. Today is the last day of this, and this is really important in the era of so many things happening, and you can see how this is done right from the non-for-profit origins. So this is a great example for you to contribute your knowledge, ecosystem connection, if you're living in Christchurch or Otatahi. Thank you. And today's the last day, as I told you, 5 p.m. Again, the last shout out. And then we're going to the next one. So yeah, 2023 AGM, 70% is sold out. This is entirely for the members only event, end of the year event, and we have a lot of fun things to happen. Tech Fight Club and quizzes coming again, and we have an additional Tech Fight Club happening as well. So if you are a member, please feel free to do. And students are unfortunately not invited for this, but please feel free to. The companies or individuals, you are more than welcome to come. And there's also a multi-core world that is happening in Christchurch for the first time. That is a multi-day event that has a lot of things happening, bringing to Otatahi. So make sure you are being part of it, and Google them and find the tickets as well. So we're going to, and also for the calendar, so we have the entire list of things happening with Otatahi and Christchurch in this Canterbury Tech calendar. So we have worked a lot to make sure that all the events are aligned in a lot of good, balanced way. So make sure you follow the calendar as well. We're going to the next one. We're going to introduce Adrian right now. Thank you, Adrian, for being part of this thing. And you've seen his experience. He comes from a good experience from being a VP of Amazon Sustainability Architecture. He's been the earliest solutions architect for Netflix, and he's also currently a partner and analyst in OrionX.net, and he's here to talk about how speeding up innovation while responding to market changes is such a necessary thing for the 2023 era. So thank you, Adrian. Do you want to take over and say hi to the group?
Yeah, can you hear me okay?
I can.
That's good.
And while he's talking, please feel free to put on your questions. I'm going to pick it up towards the end of the session. So feel free to post it in the comment section. I'm going to give it to you, Adrian.
Okay, thank you.
Thank you.
Thanks everybody for coming out for this. I was last in New Zealand in 2015 there's a conference called Code Mania. It was 3 days in Auckland. So I obviously spent, oh, somebody else's needs to mute. Okay. So I came for 3 weeks and toured the whole island and came down to Christchurch. I know Ben Keeps, I'm sure many of you do, and lives near Christchurch. So I spent a bit of time with him and wandered all around the island. So, and I'm coming back again for Multicore World in February. So if anyone wants to chat or do anything, then we can get together then.
Nigel, right, do you want to please mute yourself? Nigel, everyone, mute yourself, please, kindly. Right. Nigel Patton.
I can
Thank
hit
you.
mute on the, there we go.
Fantastic. Yeah. Thank you. You're good to go, Adrian.
All right, so I will share screen and show you the deck I've got here. All right. Everyone see that okay? Yeah. All right. So it's a talk I've given a few times recently, and it's I think quite current because there's a lot happening right now. Things are moving very quickly. So I'm going to first of all talk about innovation and how to think about speeding up innovation, particularly in software technology terms, and then look at some business tipping points and the sort of give you some patterns to look for and things that you might be able to pick up on in your own business and your own environment. So first of all, innovation, let's think about, how do you measure innovation? What is innovation? And fundamentally, my opinion is you don't add innovation to an organization. You hear about organization people hiring a VP of innovation or building and making an innovation department or creating a research lab or something like that. What I found the best thing to do is just get out of its way because people are the people have ideas, but the problem is that the systems that they're operating in tend to just get in the way of those ideas. So how do you measure innovation? And for me, it's time to value. If you do some work, how long is it before that work reaches a customer? And for many organizations, that's months. If you're reasonably agile and you're on some kind of, sort of sprint-based model, it may be days. But there's no reason why it shouldn't be minutes. Continuous delivery means you can write some code, you can check it in, and it could flow all the way out to a customer in fact, in seconds is possible, but minutes is reasonable. You want to do a bit of testing on it, make sure you didn't break anything too badly. And so what this means is that there's no economy of scale in software. Normally we bundle things together to get economy of scale, but it turns out in software, smaller changes are better. The more things you bundle into a software release, the less likely it is to work. So what we want is lots of small changes. We want an automated continuous delivery pipeline, and we want to have tagging, feature flags, and A/B tests. We want rapid, cheap builds. So for example, if you're building your code with Java and it's one huge monolithic application, it'll take a long time to build, sometimes hours. There are some systems out there that sometimes have taken weeks to build. So the Symbian operating system that Nokia had is a good example. It literally took them weeks to try and get a build together, and they were trying to get a release together once a year because of that. There's people in the waiting room. I'll just keep hitting admit when I see that. Hopefully somebody else is also doing that. And then if you look at the Go language, if you've ever written anything in Go, you type Go build and it just returns, you get the prompt. It's super fast. It's usually sub-second to do a build. And then the other thing we did, we moved to microservices, so you're only building a small piece of the system each time. So if you're working with maybe a language that doesn't need compilation and microservices on small pieces, you tend to be going faster anyway. So what we want to do is change one small thing at a time. That means it's easier to tell if it breaks, it's easier to roll back, and it's easier to measure that time to value because you did one thing and then it shipped. The more things you bundle together, the harder it is to figure out when that time started. You're kind of averaging things. So we also want to decouple new code from new features. You want to be able to change things by doing lots and lots of small changes that customers and users don't see, and have lots of small safe updates. And once you've figured out they work, you turn it on for testing. And once you're convinced that that's all working well, then you turn it on for everybody. So with small changes, there's less risk, faster problem detection, faster repair, less work in progress, less time merging changes because you check code out, do something, check it back in again. The next person checks out the code you did yesterday and makes their change. So you tend to get less merge conflicts and happier developers and faster flow. So how do we get there? First thing to do is try to measure time to value, either commit to deploy, which is usually you can instrument fairly well just looking at your build system, but also idea to delivery. How long do ideas sit on the shelf before somebody finds time to try them out? Because that idea might be a big win. It's very hard to tell which of the portfolio of ideas that people have are going to be winners up front. It's best to find ways to test all the ideas people have because it's usually one of the more obscure ideas that turns out to be the biggest win. So you want to learn to do small things quickly. Don't try not, if you've got a slow system, don't get bogged down in speeding up everything. Create a new fast path that you sort of qualify into for simple, safe changes, things like user interfaces or metrics or monitoring changes rather than core functionality changes. And then automate canary and chaos testing to make new ideas and changes safer. I've done whole presentations on chaos testing. I don't really have time to get into it today, but one way of thinking about that is if your system's fragile, then people don't want to change it. If your system's robust, then it's safer to change and to move faster. The analogy I have is running with scissors. If you have kids and they're holding something sharp or fragile, you say, don't run with that, walk carefully, right? So you have to go slowly. If you can wrap those scissors in some packaging or put the piece of valuable china in a box, you can run with it, right? You can ship it, you can send it fast. It's so something about wrapping things up and making them safe, which is one of chaos engineering is the way that you test to make sure that you have got those safety and resilience things in place. Then that makes it safer to go fast. So there is a benefit to having a system that's resilient. So you really want to just measure the cost per deploy, build and test cost in dollars and people, how many hours you spend in meetings and things like that, reduce that. And then you really want to have no meetings for each deploy. It should just be something that people can see in the ticketing system as one ticket that tracks this thing all the way through and automate everything. So a few books that help along the way here. The original book, I was at Netflix from 2007 to the end of 2013. And this is the book by the original CEO about how Netflix was founded. His wife said that will never work. But one of the things here is that he's a product manager, had a testing mindset from the very beginning. So Netflix has always had a very strong hypothesis testing, A/B testing kind of ethos, and everything they do is tested. There's really nothing that gets out the door that hasn't gone through some kind of testing. And then this was written up later on as hypothesis-driven development. Lean Enterprise is a great book to read. And I know the authors fairly well, and they sent me an early version of it, and I was just pushing this book for a long time before they finally finished writing it. And one of the authors, Barry O'Reilly, wrote this book called Unlearn about if you're stuck in the old way and you have to break away to get your new ways of testing, new ways of working. And he did something sneaky in this book. If you ever write a book, one of the key things to do is put a very well-known celebrity in the book as an example, and then send a copy of that book to the celebrity and hope that a paparazzi takes a picture of them reading your book. And that's how he ended up getting a few points, a few places further up the bestseller lists. The other thing, again, Jez Humble was one of the other authors from Lean Enterprise, and he worked with Nicole Forsgren, who's a statistician, and she did a lot of really deep analysis. I'm sure some of you know about the DORA metrics that are in this book. So this really is the not just correlation, but causation. Their survey data, and they figured out that low latency time to value gets you better outcomes as a business. This is a book you may not have run into. This came out quite recently, and there's a forward by me. I basically badgered this guy to Dave Anderson in particular. He said, I'm thinking of writing a book, and said, oh yes, you should definitely do that. I introduced him to the IT Revolution people who ended up publishing it and wrote a forward for it. The thing about this book, it contains a few interesting techniques and puts it all together into a process that lets you go way faster than I've seen anyone else go. And this is not for a little startup company. the authors were working at Liberty Mutual. It's a roughly 150-year-old insurance company based in the US, and they're the sort of development organization based in Ireland, and they were going so fast that they just they put one team on a training class, and then that team like for half a day, and then that team played around a bit the following afternoon. Then they built an entire product from scratch the next day, from the beginning to complete rollout to the customer, and they were testing that with the customers that afternoon. And they said, yeah, that was cool. That went pretty quickly, but I think we could do it in 2 hours next time. We don't need a whole day now that we've done it once. It's off the scale compared to everyone else I've seen. And this was a pretty complex system that they built from scratch. Not just a new patch to an existing system. They deployed completely new hardware and systems to do it. So with time to value, what you're trying to do is learn to do simple things quickly to unblock innovation and avoid the sort of complex one-size-fits-all processes. You end up with a lot more variation, and it gets a bit complex. So the best IT architecture today is actually minimalist. You don't want to over-specify an architecture. It's probably pretty messy and inconsistent because it contains things that are old and things you're experimenting with, as well as your sort of mainstream thing that you think generally works. If you're doing something you just want to get it done, you have a mainstream way of working, the sort of well-trodden path. But if you don't explore the new things, then you won't evolve. And you need guardrails to make sure that the things you're trying are secure, scalable, available, but you don't want to over specify, say what language it's in, what framework it's in, things like that. So you end up with a bit more of a mess that you have to tidy up occasionally. But if you try to make everything too tidy, and I tend to see this problem, somebody hires a new CIO and they say, this is way too complicated. They tidy everything up and they're actually killing the ability to innovate in your environment. So you want to be able to evolve rapidly, explore new technologies and opportunities, and have low latency continuous delivery is the key thing that matters. All right, that's what I have on just sort of thoughts about innovation. I'm going to talk about some tipping points that I've seen and lived through and give you some examples. Okay. So a tipping point from a business point of view is when something that was expensive becomes free, or something that was cheap becomes expensive, and a new disruptive business model emerges. And the real question is, can you innovate fast enough? And really what we're talking about here is ecosystems. And an ecosystem evolves faster than its inhabitants can adapt. They die out. We're seeing this with coral bleaching and things like that in the ocean. We're seeing it on land as climate moves around. But fundamentally, for businesses, when markets evolve faster than companies can adapt, the companies fail. That's the key thing we need to think about. So Netflix, I was there. This is an old Netflix thing. Netflix used to ship DVDs, and then they added streaming as watched instantly. And this is in about 2008 or so, something like that. And you can see there was the content wasn't particularly great, but this is what we had. This is how it worked at the time. The cost drivers, the cost of goods sold for Netflix at that time was about $2 per movie that somebody watched, because we had to ship them a DVD and back, and we had to buy the DVD, which cost, say, $10. And after it had been shipped 10 times, it was too scratched or broken on average. So we had roughly $1 of DVD cost and $1 of shipping cost for every movie somebody wanted to watch. And at the time, we were charging $8 a month. So if you watched more than 4 things a month, which you could actually do fairly easily, you were an unprofitable customer. But on average, customers watched less than 4 things a month, and Netflix was profitable. And that's how it worked. So then and the shipping was the US Postal Service, which Netflix was the biggest customer at that time for first-class mail in the US. So after we added streaming, which came on in 2007, we modified our monolithic backend. We added a few more things to it. But the key thing that happened here was the cost to stream a movie was vastly less. It was more like 10 cents. And then the content licensing was a fixed amount. And the more people that watched it, then the cost per view went down, right? And then by 2013, we'd moved everything to the cloud. and we had our own CDN. And the cost driver per view at this point, the cost driver view, the IT cost, the delivery cost was, I mean, there was a cost, but it was really in the noise. It was tiny. Really, the cost was totally dominated by content licensing costs. So Netflix went through this sort of phase of development where it became much more of a content company because that was what was driving the costs. And if we look at what happened here, there was a tipping point because if you go back in time to say 2004 or so and try to stream movies, the cost to stream a movie would have been $10 or more, $100, something like that. It was definitely more than Netflix could afford. So Netflix was watching the ability to drive that cost down, and it was going down by sort of an order of magnitude every few years. This is very indicative, but this is sort of roughly the way to think about it. So you've got the cost of the way you currently do business decreasing slowly, and you've got the cost of a new way of operating your business basically trending to zero, but you've got to intersect the point where it was horribly expensive and the point where it becomes free effectively and catch that tipping point as it happens. One of the other things in the Value Flywheel book is it talks about Wardley mapping. I'm not sure if you've seen Wardley mapping, any of you, but this is a way of mapping a value chain against how it evolves. So the way to look at this, if you look at the top left, there's Netflix streaming, and the value chain is you need a CDN, and they built it on on a rapid prototype running on some servers. And those servers were distributed into these global points of presence where the internet connects. There's a place in each major city where you can plug into the internet at a very central point. So we kind of plugged in there. The first CDN was really a prototype. It was hacked together. And then we found that we had enough business to interest the main CDN vendors, the product. So we went from a custom-built thing that we'd custom-built ourselves using some technologies that most people weren't using at the time. And then we went to a product-based. So there's a migration. And what we found was the CDN vendors had spare capacity in the evenings when Netflix was busy, so they could sell us their spare capacity super cheap. That worked fine until Netflix became so big that it overran the daily peak traffic from business. And at that point, the CDN vendors couldn't afford to support the scale, so Netflix built its own very industrialized, very optimized sort of commodity-based CDN that, again, is custom built for it. And it's still, I think, the largest CDN in the world in terms of volume. So there's sort of two transitions here that Netflix went through, each of them caused by something becoming expensive or something becoming cheap. And in whenever it was about 2013, there was a company called Sandvine put out a report saying, by the way, Netflix is about a third of the internet's capacity, and everyone freaked out because up to that point, no one had realized that Netflix was succeeding. Everyone thought Netflix was going to fail. So there was this tipping point where it became obvious that Netflix was winning, and then all the other streaming people were in denial for a bit, and then they all started trying to copy Netflix. But Netflix had a free run for a while to figure this stuff out. Like I said, Netflix is now a content company, and this is their current content spending. That is in billions of dollars annually, $18 billion in 2022. Right? That is very hard to replicate. It's a huge moat around the business, but the cost of the streaming bit, the technology cost, the delivery cost doesn't even register on this chart. So it's Netflix's. But what the other thing Netflix found was that the cost of licensing content from other people was based on the number of customers you had. And it was sort of sized to the size of the TV networks in the US. And as Netflix got to be bigger than the biggest TV networks in the US, the cost of licensing content went off the scale. And actually Netflix could go directly to the writers and get content made for less than it would take to buy. So that was the other tipping point where Netflix is now really a content-based content creation company because that's at the scale they're at, that's the cheapest way to manage content. So each of these was a big transition to the business. At one point, Netflix transitioned from a streaming service company to a content company, as I mentioned. One of the effects of that was the entire marketing department was replaced from the CMO downwards over a period of about 2 or 3 months. It was quite radical. It's like we knew the people in marketing, and then 2 or 3 months later, we had a new CMO, and literally everyone else left. Because what the job of marketing a service is very different to the job of marketing content. So Netflix went through this and is basically very good at dealing with these things and transitioning. And this is a long-term competitive advantage for Netflix. They're currently transitioning to live video, advertising, sports, and games, right? Each of those, yeah, they figured it out. Okay, let's look at some more tipping points. And this is a bit more of a personal one. This is a view from a restaurant in Lahaina in Maui, which no longer exists. The fire took it out. It was Kimo's in Lahaina, one of my favorite restaurants. And, climate is a big tipping point. So I pulled up something from the collapse of the Antarctic ice sheet, which talks about the impacts on, I pronounce Aotearoa. I was saying New Zealand. I should be practicing saying it properly. Did I get that about right? Aotearoa, yeah, something like that. All right, but it's going to impact you. All right, so there's a tipping point as the Antarctic ice sheet melts. And there's a tipping points in the North Atlantic with a meridional overturning, AMOC. It's basically the Gulf Stream current is going to collapse as well. This isn't going to happen gradually. It's going to happen gradually and then suddenly all at once. So I've been doing a little bit. Everyone should be doing their bit. The thing I'm doing is I'm working with the Green Software Foundation. There's a project to do real-time cloud. I'm trying to develop metrics that the cloud vendors we can all have the same metrics for all the clouds for how to measure green software running in the cloud. And that's a project right now. Hopefully we'll come up with a standard as we get to it, and then hopefully the cloud providers will sign up to that standard. So it's quite a lot of work, but I've been sort of banging at that particular project. So I've got a whole presentation in that area as well. So here's another one, another tipping point, working from home. Basically, over time, we gradually had a few things happen. We used to go to work because that's where our computers were, but now we have laptops and smartphones, so we can work from wherever we are. There wasn't enough bandwidth to work from home for most people, but things like Netflix and streaming TV services incented people to get more and more bandwidth at home, and then eventually to have upstream bandwidth so that people had enough capacity to run Zoom from home, various video conferencing things. So those were gradual things, but then COVID-19 lockdown pushed everybody into that transition and greatly accelerated this trend. So it was sort of the underlying capabilities happened, and then bang, it happened very quickly. And this is still repercussions happening. We're seeing, this is a McKinsey report. I've seen some more recent reports that say that companies that embrace working from home have happier employees and better outcome, higher growth rates, more profitability. So the companies that are pushing back on it are generally the ones that are being less successful. So that's another thing to just deal with as a business. I don't think you can put this genie back in the bottle. It's the way things are going to be. I've also seen some companies very good at managing hybrid work with a mixture of in-office and remote work, and it should be a corporate objective to just get good at hybrid. And sometimes that means changes in culture, tooling, the way you talk about things, the way you do things, just to make it work properly. All right, some new tipping points. And there's a lot going on in AI right now, and I'm sort of pulling together a few different things here. There's the self-driving cars. I have a Tesla Model 3. I've been using FSD now for about 3 years. It's been driving. Most of the miles I drive, the car's driving me, and I've done like 20-something thousand miles. And you pay attention to it, but you learn to do what it can and can't do. You tend to anticipate when it's going to get confused, but most of the time it's just fine. It's a better driver than I am most of the time. And then there's ChatGPT that's come along recently. Lots of fun and games at OpenAI over the last few days, but the product's still out there, luckily. And then the coding assistants like Copilot, Cody, and things like that. What's happening is this sort of tipping point, if you like, of AI tools becoming competitive with the average human driver, expert, or developer, and they are getting better very rapidly. And there's several tipping points here. If you look at FSD, there's a YouTube channel. This guy, AI Driver, is the name of the channel. And he does these nice overlay videos so you can see what's happening. So you can see the picture out of the window and you can see what the car is showing you. And it's highlighting, okay, I can see some green lights, so I can go, but there's a car coming, there's some pedestrians, and it's tracking. It's got an ego model for every entity here. And in real time, it's managing a safety critical thing, and it will do an unprotected left turn safely when it's able to do that. And this is, this is pretty advanced stuff. There's a lot of work gone into it. There's a lot of work in other companies working on self-driving cars too. But if you think about that kind of modeling, and then you blend that with sort of the idea to understand content that we're seeing out of ChatGPT, and the ability to sort of build complex systems and code and things like that with Copilot. If you combine all these things together, I think there's some interesting things going to happen. So there's a few things here. Comment from Uwe Friedrichsen. He says detailed knowledge, which is a big differentiator of the job market, will lose your value. If you're in an interview, people don't need to know, do you know how to use all of these languages and tools and libraries and things like that? You don't actually need to know anymore. What you need to know is how to be more like a product manager, architect, and need to know how to solve problems and to understand requirements. But the actual implementation piece, you need to vaguely know how to use the language, but it will mostly get written for you. So there's some interesting sort of transitions here in the job market as well. So where could all that lead? Basically, there are some things that were hard that are becoming easy. Personalized art, music, stories, the sort of ChatGPT kind of thing. And then it may become easier to adopt new language APIs and tools because I don't need to be an expert in this entire framework in order to use it. I just need to vaguely know how to use this language maybe, and the detailed knowledge of the framework is held in the AI system. And then this idea of conversational development where you just chat back and forth with the system and it interviews you and then it produces the application. So how do we optimize for this world? Well, back in the day, you might remember a long time ago, we built web pages for humans to read. But nowadays, we build web pages for things like Google search engines to read so that Google will send people to your web page. Right? So that search engine optimization has become a huge industry. What's the equivalent of that for AI? How do we do AI optimization so that this new tool or this new library or this new product that you've made, that the AI systems know about it, so that when somebody asks the AI how to do something, it says, oh, there's this thing over here you should use. How do you make that work? It's not clear, but that's I think, going to be emerging. And then there's this other thing is what level of languages work well with things like ChatGPT. I saw a blog post yesterday. Somebody found that Julia and R for data science worked really well with ChatGPT, but writing code in C and C++ was terrible. It just did a terrible job at it. So there's something about the way the languages are, and typically higher level languages work better with the AI systems than lower level languages. So maybe we abstract languages and services into much more annotation based, very high level constructs, because then we get reliable output from the AI systems. And then this big issue around, and the US the White House just put out an executive order on this, labeling when AI is being used, insight into its actions, really sort of trying to police AI so that we know what's happening with it. So how fast is this moving? I'm just going to wrap up in a minute, but most companies are replanning their product roadmap now. In fact, some people I'm talking to are replanning it continuously because they keep thinking, oh, here's an idea, we'll go start building it. And then one of the AI companies says, oh, we've done that. Okay, well, let's build something else. No, we've done that. So you're kind of iterating, trying to find something that hasn't been done, that looks like it's plausible to do, that is far enough ahead of the rest of the world that you actually get to finish building it before somebody else does. I think most people are underestimating the rate of change. This stuff goes exponentially. You tend to overestimate the impact in the short term and radically underestimate it in the long term. That's just the way humans are. And just as one example, there was over $17 billion of venture capital investment just in Q3 this year. And that was up significantly from Q1 and Q2. That money goes somewhere, right? It's being used to build all these things. So trying to stay ahead of this is a huge wave. If you're a surfer, this is an enormous wave. The people that can innovate fast enough to catch that wave and ride it are going to survive, and the people that get knocked over by it or whatever are going to be sort of the people that we are picking up the pieces from. So I asked ChatGPT a few questions. I like to do this in this talk, make it a bit current. So this is the entire chat I did in ChatGPT on my phone in like 3.5, the boring version of ChatGPT. What tipping points should people be concerned about? And it gave me a bunch of things about climate-related risks. But then I tried to make it, okay, what local businesses will be affected most? Then it says, okay, it seems to know that Canterbury has agriculture, tourism, water-dependent activities. And yeah, it's basically telling you to be sustainable. So like, we could probably continue that conversation, but it's just sort of to give you an idea of the sorts of things. If you can't think how to do something, there's lots of good advice in there. You have to be able to sort of tie it back to the real world so that you don't get too much hallucination kind of things. But anyway, that's what I have. I think what's next is up to you. I'm interested to see what people are up to. And like I said, I'll be there in February, and I'll be around Canterbury all week at Multicore World, and I'd probably be happy to see some people while I'm there if people think there's something interesting going on. And I'm working with, as I mentioned at the beginning, I'm working with Mark Bregman, who's an Edmund Hillary Fellow, and he's the guy who runs QuidNet Ventures, which is a VC firm that only invests in New Zealand. And I've recently sort of joined to help him with that fund. So we're looking also for interesting startups and ways that we can help. So let's just go to Q&A then. I think hopefully we've got some time left.
Awesome. Wow. That's a lot of things to unpack and reflect on, actually. I am going to wait until people put in their questions, but I think maybe I can start with something that is already there. Oh, there's no particular set of questions. Okay, I have a few questions. Maybe I can start with some of them as such until somebody has that they want to add to. So
I do see a question here about UIs from Andy
oh, there
Masters.
is, I think, yeah, okay, the Andy Masters, yeah, for sure.
So, yeah, users getting confused if the UI is continuously evolving. So this is actually an interesting point it brings up, that when Netflix runs its A/B tests, it does it on fresh new users who have never seen the product before, and you get a much stronger signal. So if you've got new people signing up all the time, they are the people you want to allocate into your A/B tests because they don't have any preconceived notion about the way the product works. They also tend to be the most active users because they're figuring it out. People tend to overuse a product for a bit until they figured it out, and then it sort of settles down. So you get a vastly stronger signal from new users. And then once you've figured out something that makes a significant difference, you introduce it to the other users, your existing users, and you maybe have a holdback test where you keep a few people on the old version just to make sure that you're not annoying people too much and things like that. So that's kind of how I've seen a sort of a good process for thinking about particularly user interface changing and not confusing people.
That's fantastic. I think one of the things that I was curious about is like your theme of the talk is around empowering smaller product teams and being very agile, and how do you encourage like collaboration, knowledge sharing across these decentralized teams, or and what role does internal open source practices even play in that regard?
Yeah, it is a big problem. You have to set up some systems, some processes, if you like, or some mechanisms for sharing. You want to have a learning organization. And one of the things is if every team is working independently and they each have the same problem and they're not talking, then you're trying to solve the same problem over and over again, right? So there's sort of a development version of that and an operations version of that I've seen in different places. let's talk about the operations version of that, which is something that AWS does. I was at AWS for quite a few years. AWS has a weekly operational quality meeting, right? It's typically on a Wednesday morning. And what teams are expected to do is they they get together on a Monday and they review the previous week. They say, okay, this is what happened. They pull up all their dashboards and they sort of just talk through operationally what happened last week. What glitches did we have? What did we push out? What went well, what didn't, at the team by team level. And those are written up into little reports that then roll up into the directors and the VPs through Tuesday, and they're reviewed on, through, say on Tuesday, you have like the more senior management do their reviews, right? Then there's a central meeting where every AWS service team, and there's hundreds of them nowadays, has to attend, and they go through and they review the big issues that are going on. But then they have a roulette wheel that has every team in it, and they spin the roulette wheel, and it picks somebody at random, and you have 10 minutes to explain yourself. And if you're not on the call, that's bad because C-level execs are on the call, and you're wasting their time, and it's not good for your pay for your reviews and things. So it's a career limiting move to not be there. And then you have to pull up your dashboards and show that you actually know what's there and that you did have that meeting on Monday. So it forces everybody in this sort of uh, putting some peril in the system, if you like. So they typically get 2 or 3 spins of the roulette wheel at every meeting, and it's just going to pick someone pseudo-random. It won't pick the same one twice in a meeting. So that wheel is actually open sourced. If you go to AWS, you can find the source code for quote, the wheel, and there's a talk or a blog post or something that describes it. So that's a really nice practice, because what you're doing is there's like systems thinking. You're creating a feedback loop that causes people to do the right thing. And then because everyone's on that call, everyone that has an issue, like people are always getting certs timing out and breaking things, right? That kind of failure. Everyone hears that. Everyone knows, okay, we should go check our certs. There's a system for checking certs. Everyone should be engaged in it, right? Everyone's hearing the same quality problems, and there's a very good institutional learning. It's one of the reasons that AWS, from an operations point of view, is one of the best out there. It's because this is a really tight system that was set up a long time ago. On a developer area, going back to some things we did at Netflix, we would have like every other week or so a manager meeting, and we'd talk about what we were doing, and we would share ideas. So if some team was going to try out a new technology, at that meeting you'd say, hey, we're looking at playing with this thing. And then 2 other teams maybe would say, oh yeah, we're interested in that too. And we say, okay, let's form a little subgroup to go off and experiment. So at Netflix, you could try anything new, but and the point was, the big rule was you had to tell everybody you were doing it before you did it, and then report out afterwards what you found out. Those were the 2 big rules, right? And those were shared across the entire engineering organization. So that way, individual groups scattered across the organization would go and sort of pathfind odd little things and discover them. And Netflix got very good exploring new technologies because of that, without having it be sort of happening in silos where nobody knew it was happening, right?
Thank you for that. And then Atlog has asked, do you rate Gartner hype cycles, or does AA break the mold?
I think no, the hype cycle definitely works. There's the peak of inflated expectations, which you get into, and the what they call it, the valley of despair or whatever it is, and then you end up back where you are. I just think that the AI is a more extreme version of that, because it's so big that is disrupting so many people so much. There are startups that are literally going out of business because of announcements that happened a few weeks ago in the AI space. Like, okay, my entire business model just disappeared. You can get it for free from OpenAI or Anthropic or something like that. And we're seeing the platform typically when a platform comes out like AWS, say, people build things on the platform and then AWS gradually sort of the platform gets more capability and some partners or software vendors get grumpy because their business gradually gets taken over by AWS, or pick any platform business, they all behave like that. It's just normal, right? Everyone's going to complain, but it happens. The problem here is it's happening like 10 times faster than anyone can deal with it, right? It's this pace of it happening that's the issue. And if you're operating at all in the AI space, you have to be super on top of this because you can be out of business very, very quickly.
Yeah, just overnight,
right now.
actually. Just when I
Yeah.
remember the last time as well. Nicholas Erdodi asked, I understand that you're working on something new. What's the tech vision for your presentation for Multicore World in Christchurch? And how can you relate it to Canterbury ecosystem?
Oh, yeah. I'm doing a very geeky thing. So Multicore World, the people that are there, a lot of people are from the high performance computing community. We were all at supercomputing a week or so ago. And what I'm interested in, it's kind of a day, the theme is a bit like a day in the life, right? There is a sort of a type of talk which is you take a thing and you walk it through its life cycle, right? Quote Adele. I'm doing a sort of a day in the life of a message, right? Okay, you have some code and it wants to communicate something to some code somewhere else. What actually happens? Right. So, and I'm looking at it from on there's I have to do quite a bit of work to actually put this together. This conceptually what I want to do. The AI training systems right now are moving hundreds of megabytes in a single message. They gather together like a few hundred megabytes of data, and then they communicate that to another machine that then unpacks it and spreads it out to use it. So it's a scatter gather. It's really gather, scatter. But the individual message being sent isn't a tiny little message. It's a 100 megabyte message, right? And when you're doing like transactional calls, you might have, a line of text as your SQL query, and what comes back is a few rows of your database, right? Those are much smaller. So even with those, it's pretty inefficient. But as you're moving around these very large amounts of data in HPC or AI systems, the overhead of how many times did that data get copied on the way out? Did it get encrypted or turned into a JSON object on the way and turned back into binary? Or, all the ways that things get mangled up along the way, and you wonder, why is this so slow, right? And it's because of all of the crap that's going on in between. So I'm trying to, there's enough open source here that I'm going to be trying to read the code and figure out what actually happens and put together. It's like a millisecond in the life of a megabyte or something like that. I forget exactly what I just said I was going to call it. Anyway, this is just me getting geeky and getting deep into the guts of the system. And I've been wanting to do a talk like this for a while, so I just decided to try and make that my new talk.
People love geekiness in Christchurch, so you're more than welcome to go hard on it. D. Branton asks, how long do you think that AI APIs will actually remain free for? Aren't they running at a loss already?
It depends, right? So the big training jobs are very expensive. Like they're sort of I think there's a good analogy for this. Like growing a human being is very expensive, right? When they get to be sort of teenager, they turn into something that's useful as an intern, right? And you can train an intern to do something. If they get to be a college student, they're a bit more useful. The AI systems we have right now are sort of somewhere between intern and college student in a base capability. You then retrain them to do, with sort of prompt engineering and sort of fine tuning to do an actual job, right? They've got a base level of capability. So most of the things that people are doing are this sort of retraining. But then, the people that are doing these enormous, expensive jobs, they're doing the equivalent of creating a human from scratch, each time, right? Like you're trying to get a lifetime of knowledge into something, and that's expensive. But to actually get a job done, you pick up one of these pre-trained models, whether it's from different vendors and from some of the open source ones that have come out of Facebook and others, and you're mostly doing a fairly quick retrain job that can be done on a laptop or on the cloud for a few dollars, and then you've got your base capability, but something that solves your problem. So I think that's the difference. It's not like these things where you used to be training things, is this a cat or a dog or whatever, right? And you just started from scratch, gave it bazillions of examples, and those get more and more expensive. It's this ability to retrain and fine tune on top of a basic capability that's giving us the ability to do this efficiently.
I'm going to ask maybe one or two more questions max. I have one question about the sustainability that was the core of your thing. Michael L asked, what are your thoughts on how to overcome the tendency you mentioned with underestimating the long term and overestimating the short term value, where computing for budget with allocating resources for incremental improvements to existing products? Business allocation to new idea whose value is underestimated. The idea explored in the book, The Innovator's Dilemma.
Yeah.
Yeah.
You have to be really conscious of it. The real problem with the innovator's dilemma is if somebody figures out how to do something that's an order of magnitude cheaper than the way you do it, but they meet the same need, because you can't just cut your price to give everyone a 90% discount because your business goes away, right? Your run rate, you can't afford to cut prices that aggressively, right? So that tends to be the innovator's dilemma, is that you will tend to get new entrants in a market that figured out a new way of solving that problem that's somehow, say, an order of magnitude or significantly lower cost, and that's the blocker. But in terms of just be conscious of it. Just think, yeah, something that doesn't quite work today. What I've seen, particularly in AI, is people making statements like it can't do this, and 2 weeks later somebody said, well, I took that as a challenge and now it does that, right? So one way to do it is to kind of work from sort of limits of physics-based principles, to say, well, this is the limit of what is theoretically possible. I mean, you can't break the speed of light. There's a few things you can't do. Conservation of energy, speed of light, stuff like that, right? Those ones. Within that, though, the ability to the amount of energy or work it takes to build a model is now going down by orders of magnitude every month, right? So that's one of the problems with trying to sort of get a stake in the ground to build something in this space. So that's kind of, but yeah, you just have to be aware that. So one of the things you can do if you're trying to predict the future is figure out what will happen, but not when, right? The sort of the Heisenberg principle. So I'd concentrate on figuring out what is going to happen and have like a portfolio of possible whats that might happen that you're ready to pull the trigger on when the thing happens, right? So you have to sort of do scenario planning and saying, well, what if somebody does this? What if somebody does this? What would we do given all these scenarios? What if these things could be built? What would we do with it? And try to maintain a very broad portfolio of ideas, which is why this ability to try out lots of ideas matters. And an idea that only one person thinks is good is still worth trying. If one person has conviction, you should go try it out, and you should make it cheap to try out that idea, because they may well be the person that may be the idea, right? And if you have 100 ideas, a third of them will be terrible and make it worse. A third will make no difference, and a third will be great. But you will not know which third does which until you test all 100, and that's kind of the hard part of having lots of ideas. If you pre-guess, then you'll miss the good ones.
Right. I know we're over time, guys. I think I have one more question in terms of sustainability, and then we'll wrap up in 2 minutes as such. So, like right now, Adrian, like the last 2 years has been a really exceptional in terms of the AI and ML training, like computing systems, and also the number of chips that is coming out in terms of making this faster. It's also happening like NVIDIA's GH200 super chip, and Azure released a Cobalt 100 and Azure Maya super chip as well to kind of make this faster. So what are the emerging approaches that are technology that shows promise for optimizing, greening these resource intensive applications?
Generally speaking, if you want to optimize a workload, you want to run more efficiently. You want to use the latest technology, which is the lowest, the latest process technologies from the silicon point of view. You get more power per watt. You're seeing this with sort of the AWS Graviton ARM chips, the latest NVIDIA chips. You get more performance for the power consumption. Right? If you go to a 3 or 4-year-old GPU, it uses the same amount of power, but it's say a 10th or a 100th of the speed, right? So you want to, so the latest technology will give you usually a price performance and a power performance advantage. The other thing in sustainability is that the grids are cleaning up. The cheapest energy you can get right now is renewable energy. So pretty much all the investment in the world is now going into renewables. There are still some few people backsliding here and there, but I think that is what's really helping. And the Green Software Foundation is a great way to get involved if you want to. There's a lot of activity and recommendations coming out of the GSF right now.
Are you also following the Aspinity's analog computing as well?
For analog computing, I mean, I'm old enough to remember analog computing, but I haven't been tracking any recent developments in that space. In effect, quantum computing is effectively analog computing, right? That's the modern analog computing, and they are getting. I was talking to somebody at HPC who says, well, we have these these laser tweezers, quantum tweezers, where you move individual atoms around, and I was like, oh, okay, this crazy stuff. But yes, they now know how to move individual atoms around, and they put them next to each other and zap them so they're entangled, and they spread them out and they stay entangled, and they have arrays of atoms. But it's all crazy stuff. But they're actually making pretty good progress there, and it's still an area where there's huge investment and the return hasn't really happened, but it's looking pretty promising that there's some interesting stuff happening in quantum computing.
Fantastic. Thank you, Adrian. There's apparently a lot of questions